All right, number 6 on those target 4 packet proofs. I don't have the picture again, but you can just follow along with your own packet. So my first step in this proof, I'm just going to write out my givens, just like I always do. So P is parallel to R and T is parallel to D. And that's just given to me. All right, so my step 2, I'm just going to start making some observations here. I'm trying to get to the fact that 1 and 4 are congruent, but I can't hop across the diagram diagonally like that. So let's see. I'm going to go from 1 to 3. I'm going to go across. So I'm going to say that 1 and 3 are consecutive interior angles because they lie on the same side of the transversal T that cuts through P and R. So if you kind of cover up the bottom portion of that diagram, you can see that T is the transversal and it cuts right through P and R. So 1 and 3 are both on the interior of the diagram and they lie on the same side of the transversal. So those are consecutive interior angles. So angles 1 and 3 are consecutive. I'm abbreviating that a little bit. Interior angles. And I'm just making that observation. So I'm just going to say that that reason is the definition of consecutive interior angles. All right, and then I can make a conclusion with that. I'm going to go ahead and say my step 3, because I know those are consecutive interior angles, I know that those are supplementary. So angles 1 and 3 are supplementary. And that's actually stated in the consecutive interior angles theorem. And I created an if-then statement between 2 and 3, so I can go ahead and draw my arrow. My step 4, I'm going to go ahead and move on from 3, I'm going to move on to 4. So I can actually draw a conclusion between 3 and 4. 3 and 4 are also consecutive interior angles. If you cover up the right side of the diagram, you can now see that 3 and 4 have a relationship. So 3 and 4 are also consecutive interior angles. All right, and that's just the definition because I'm just making that observation. So definition of consecutive interior angles. All right, and then I can draw a conclusion from that relationship. So I can say that because 3 and 4 are consecutive interior angles, they are supplementary. Just like I did from 2 to 3. And that is the consecutive interior angles theorem. And I created another if-then statement between 4 and 5, so I'm going to draw my arrow. And then step 6 is a little different than what we've been doing. Kind of have to think back to our unit 2 now, because we can draw a conclusion here, but it's a little bit tougher to see. So we have a couple things. We know that 1 and 3 are supplementary, right here. And we know that 3 and 4 are supplementary. Well, there's a theorem called the congruent supplements theorem that we learned in Unit 2 that states if two angles are supplementary to the same angle, then they are congruent. So because angle 1 is congruent to angle 3 and angle 4 is congruent to angle 3, 1 and 4 must be the same measure. So they must be congruent. So angle 1 is congruent to angle 4. And that reason there is called the congruent supplements theorem, if you can recall from Unit 2. and I grabbed that from my step 3 and my step 5. And I'm done.